Hi, everyone. This is Jennifer McCarthy, the VP of Legal Advocacy for Federated Wireless, and joining me is our CTO, Kurt Schabach. We spoke yesterday on a couple of panels regarding spectrum sharing and the work that we're doing in the United States to make spectrum sharing in the 3.5 gigahertz happen on a commercial basis, as well as our efforts to bring the 6 gigahertz band on a sharing basis for unlicensed devices. Could we go to the next slide, please? A little bit of background on Federated Wireless. We're all about, this is our background and our bread and butter. We are one of the certified system administrators in the United States for the CBRS band at 3.5 gigahertz. We are deploying our cloud-based software network to enable the sharing of that band between federal incumbents, which are naval radar systems, some fixed satellite services, as well as a number of grandfathered broadband wireless access licensees who are going to be moving over to the CBRS rules later this year, coming in October. But our cloud-based system enables that sharing between those different systems in conjunction with a sensor network, an environmental sensing capability network that we've deployed along the coasts of the United States that listens for those naval radars. We also interact with the FCC's Universal Licensing System database in order to identify and protect the fixed incumbents in the band, such as those fixed satellite services. We are enabling the access of this band and 5G networks, both those being run by operators, cable companies, as well as WISPs, wireless internet service providers, and a whole host of private networks, whether those are educational institutions, smart cities, other private networks. We have over 40 customers operating commercially on the system. And as a whole, the CBRS deployments to date are over 32,000 base stations, which is a really amazing feat in the 9 months that we've had since we were authorized to be commercial in the US, and particularly during the COVID crisis that we're all going through. Next slide, please, Rebecca. Oh, Rebecca, it looks like we've lost our slides.
I think we might have just lost Rebecca. Hang on one moment. Let me try it from my side.
Okay.
Here we go. Let me.
In the meantime, I can continue to tell you about the work that we're doing to make 6 gigahertz sharing possible. So as you may know, the US FCC, the regulator, telecom regulator here in the United States, in April of this year, adopted new rules to enable sharing of the 6 gigahertz band. They are allowing low power indoor devices as well as standard power devices, whether they're indoors or outdoors. They have required the use of an automated frequency controller system to manage the use of the frequencies for those standard power devices and for all outdoor devices. And that system, the AFC, is what we've been developing for the past 18 months. And we are going to be showing you a demo of that today. May we go to the next slide just to make sure we've covered everything before we jump into the demo? Very good. Yep. So the little background on the 6 gigahertz band and the work we've been doing over the past 18 months to bring this AFC capability to commercial reality. We are leading the technology and standards development effort. We believe that we've got the industry's only commercially ready AFC that's been demonstrated to the unlicensed Wi-Fi community, working with the incumbents whose protection we are administering, and with the FCC, who is going to be going through the certification process for AFC later this year. We've also started working with all of our OEM equipment partners and operators to develop the ecosystem and start interoperability testing. And with that, I think we should jump into the demo of the AFC, and then we'll turn it over to folks to see if they have any questions. Lula, may we start the video, please?
Hi, this is Sam McMullen from Federated Wireless. After this technical slide detailing the AFC theory of operations, I'll then demo Federated's AFC. We've been working closely with the FCC, incumbents, and the unlicensed community over the past year and a half to develop and refine this operational AFC system. An AFC calculates protection contours around each of the more than 100,000 incumbent receivers using details such as incumbent transmitter and receiver locations and antennas as extracted from ULS. Federated's AFC stores in the cloud about 1,000 pre-computed contours for each incumbent receiver as the needed protection level and height increases. Higher power devices result in a larger protection contour, as is usually also the case with devices higher above ground, where, for example, losses due to clutter are less. More than half of the incumbent receivers use a 6-foot antenna, which is well modeled using the UHX-6 antenna mask. If the incumbent receiver instead used a 12-foot antenna, it would result in a narrower protection contour relative to what would be generated for a 6-foot antenna. For example, as shown in this slide, using the UHX-12 mask instead of UHX-6. To determine the spectrum availability for a device, the AFC first creates a circle around the device reported location with radius equal to its position uncertainty. The AFC then extracts from its database the set of nearby protection contours that match the device transmit power and height and checks which contours are overlapped by the device circle. If there's an overlap, then that incumbent's operating frequency is excluded from what is reported as available. A portion of the band that remains after this check is then reported back to the device as being available. Federated's AFC is designed with the user interface that emulates a request from unlicensed devices for spectrum availability in a particular location, given information such as the device location uncertainty, height above ground level, channel bandwidth, and transmit power. The emulator makes the request to the AFC using a standard and secure internet connection, gets the AFC response, and then shows on a map the reported incumbents needing protection and plots the available spectrum. So I'll demonstrate availability in New York City, which is of interest as the incumbent density in New York City is high. Nonetheless, as we'll see, there's abundant 6 gigahertz spectrum for standard power operation. So first, let's consider a device in Manhattan with latitude and longitude as specified here. We'll assume full power operation for standard power devices, which is 36 dBm. In this case, we'll first assume that the device wants to operate using 80 megahertz. That translates to 17 dBm per megahertz. As there's still some discussion on the most appropriate billing entry loss to assume for indoor operation, we also allow a penetration loss to be specified to the AFC. So in this case, the device is outdoor, so I'll set that value to 0. A typical device will be down in the clutter, most commonly around 3 meters, which I'll enter as the height above ground in this case. Per FCC rules, we'll use an incumbent protection criteria of -6 dB for the interference to noise power ratio. And for demonstration purposes, we'll also assume each incumbent receiver is modeled using a UHX-6 mask. Ultimately, the AFC will use the antenna make and model information in ULS to determine the antenna pattern. However, as the current ULS information is somewhat inconsistent, our current AFC release allows us to manually enter in the antenna pattern to assume for all incumbent receivers. Again, here we assume UHX-6. So in this case, we find that 1200 megahertz of the band, all 1200 megahertz, between 5925 and 7125 megahertz, is available for standard power operation. Our AFC currently reports all of the bands, all the uni bands between 5 and 8 in terms of their availability, not just Uni 5 and Uni 7 as per the FCC's newly adopted rules. So in future releases, we'll show just Uni 5 and Uni 7. But with that said, in this case, we see that the whole band is available and incumbents are protected throughout. So let's suppose instead that we wanted to model availability assuming a 20 megahertz channel instead of an 80 megahertz channel. In this case, 36 dBm translates to 23 dBm per megahertz. And to save time, I ran this case earlier and saved the result. In this case, we see that 950 megahertz of the 1200 is available, including all of Uni 5 and Uni 7. So looking at one of the Uni 8 incumbents, we kind of see a typical protection contour. For example, in this case, the device is shown here in red, and the incumbent protection contour for a receiver that's located a little bit to the north of the device location is as shown here. In this case, the transmitter is actually located down in New Jersey. But we see typical protection contour where it's long and narrow spatially, starting from the receiver. And again, if we had used UHX-12 instead of UHX-6, the antenna pattern would have been even more narrow. So continuing on, let's suppose instead that we wanted to put the 20 megahertz device above the clutter. Let's just say instead of 3 meters height above ground, we'll use 100 meters above ground. So even in this extreme case, we still see some Uni 5 availability around 6,200 megahertz and some Uni 7 availability around 6,700. So let's just look at one last case. Suppose we wanted to characterize indoor operation. So suppose we wanted to go back to 80 megahertz, and in which case, we use standard power, full power operation, and that gives us 17 dBm per megahertz. But now in this case, I'm going to assume the device is indoor, and I'm going to add a building entry loss of 15 dB. So in this case, we see much greater availability. More than half of the 1200 megahertz is available, including large segments of Uni 5 and large segments of Uni 7.
Thank you. So that is a demonstration of our AFC capability that we've developed for the United States. We are in discussions with different countries around the world that are considering also making the 6 gigahertz band available for new unlicensed devices, whether those are Wi-Fi or 5G NRU, and would be able to interact and interface our system with databases that show the incumbents in that country. And then we can adjust the protection criteria according to the local national regulators' requirements. Kurt, I know that we've spent quite a bit of time working with the Wi-Fi community on this AFC and with the FCC to help design it in a way that would meet the protection requirements for the many fixed incumbents that are in the band, and also make it usable from the Wi-Fi community's perspective using some of the protocols that are already built into Wi-Fi devices. Could you talk a little bit more about that work that we did with them and some of the things that were really important for us to factor in when we developed the AFC?
Sure, Jennifer, thanks. And good day, everyone. Pleasure to be here. So, of course, the AFC operation itself is technology neutral. So it can work with Wi-Fi or unlicensed 5G for operation in the 6 gigahertz band. There were a couple of key factors that we had to work across the community on. One was really settling the propagation model and interference protection criteria. And I think a lot of the work that was done leading up to the FCC's rulemaking and final rules led to at least some consensus within the industry and adoption by the FCC of protection criteria and a propagation model. And I think those two things were very helpful in terms of accelerating the process of bringing an AFC to the market. Because clearly how you protect incumbents and how you model that, protection are topics that are often debated. And the fact that it was settled in the rulemaking was very favorable. Similarly, position determination is a big, issue that comes forward. So, and this was a particular concern with the Wi-Fi community and much debate because today, currently, Wi-Fi devices have no means to determine their actual position, provide a geo coordinate. But in working with the community, I think we've identified a couple opportunities for the industry going forward to assist with that process, in particular for these standard power devices. So if you think about the two architectures that exist for example, in Wi-Fi, with service provider Wi-Fi or managed Wi-Fi, often the access points, the RLAN devices, connect to a controller of some sort, some management system. And that management system could be utilized to, for example, store information about the location of each of the RLAN devices and share that with the AFC platform in a way that channel availability could be determined. Often those devices are installed by a technician who could enter that data in almost as if it was through some installation procedure that could even be standardized or adopted across the industry. Similarly, a lot of residential or commercial RLAN devices, those that might be used in a home or with an enterprise that doesn't have a central management system, those devices are often activated or configured through the use of a smartphone and an app on a smartphone. And that smartphone could be used as a means of obtaining a geo coordinate for the device. So when you're configuring the device, the application that's running on the smartphone could acquire the geo coordinates, and that could be pushed to the RLAN device as part of the configuration process as a way to store that geo coordinate information locally on the device. One thing that's useful to note as part of the demonstration that we just showed, you saw a GUI where Sam McMullen was entering the coordinates and the information related to the RLAN device. That's of course there for the purposes of our demo. The normative operation would be the device communicating directly with the AFC through a software protocol or API, where that information that we showed being entered into the GUI would actually be stored or available on the RLAN device and shared automatically with the AFC for the AFC to provide in response a channel availability assessment. So Jennifer, I think probably those are a couple of the highlights of things that we've been working on over the last 18 months. I'd certainly be happy to answer any questions that that our attendees have.
Great. Well, that's awesome. We have our first question is, why do we call the AFC light touch, and how is it different, say, for example, from the CBRS SAS, which yesterday we talked at length about the complicated nature of the CBRS sharing scheme and how that might not be a one size fits all for all other countries, and that other countries might want to take certain aspects of that sharing capability and implement that to address spectrum access challenges. But the AFC is a much simpler exchange than what we have to do with the CBRS SAS.
Yeah, so one aspect of simplification, probably one of the greatest aspects of that, was the decision to treat each of the devices independently in terms of the assessment of its interference potential. We call that sort of a single entry analysis. We don't do aggregate protections in the 6 gigahertz band, where we do aggregate protections in CBRS. In CBRS, we look at every device and their locations and then aggregate together the potential interference they may create to a particular incumbent. The advantage of aggregate interference protections is it leads to more dynamic and intensive spectrum sharing, because you're really looking at aggregate effects and also arguably more precise or higher fidelity protection to the incumbents. The approach taken for 6 gigahertz, with it being single entry, is a little bit more simplistic. We can treat each device individually, and the implications are there's a lot less computations, fewer computations that are required, and there is no requirement for AFC systems to peer and exchange data with each other. They can by treating each device independently, we're able to run those calculations for the device without having to have knowledge of devices, for example, that might be connected to another AFC while still providing incumbent protection. And that has greatly simplified some of the technical requirements that we had to really tackle over the last couple of years related to CBRS. And that's really where we, I think, principally describe it as a much more light touch approach.
Yeah, that actually leads nicely into the next question we've gotten from Heike about standardization of the AFC and how that's going to be different than what we went through with the SAS certification as well. You know, right now there is work going on within the WIN Forum as well as within the Wi-Fi Alliance about setting some standards for AFCs and how they would operate. And I think there is a question about whether or not that work is actually necessary for AFCs to meet the FCC's requirements versus nice to have from an industry perspective, and how much of that standards work is needed in order to get through certification and bring us to market. In the FCC's order that came out in April, they suggested that a new multi-stakeholder group be formed to address some of these questions. And I understand that the WIN Forum and the Wi-Fi Alliance are talking about organizing a new group. Oh, I think we may have just lost Kurt. Are organizing a new group to start tackling some of these issues and questions. But I'll answer my own question to that point, which is, given the lack of interoperability between AFCs, where we do not need to calculate aggregate interference and can instead compute the potential for interference on a single entry basis, there really is less need for the AFCs to communicate with one another and to have standard protocols for doing so, which makes it simpler. Kurt, can you still hear us?
I can, yeah.
I've lost your video, but
okay,
I'm
well,
glad to know.
Lula said she can see me, so hopefully the other attendees can as well. But probably the verbal part is more important than the video. Yeah,
there we go.
That's right. There are two groups that are working on standards. I think the key, perhaps key difference here versus CBRS is the FCC settled, as I indicated earlier, many of the key technical issues. The protection requirements, the propagation model, those things were largely unsettled at the end of the CBRS rulemaking process, and industry had to work closely with, in particular, a key incumbent, the Department of Defense, the US Navy, to work on the technical requirements. I think in this case, it's really an excellent question to say just how much standardization is required. I would say that the benefits of standardization around the AFC for 6 gigahertz is really a question about scale and interoperability. If equipment suppliers feel strongly, ultimately, about the need for interoperable solutions, then obviously standards are important to settle things like protocols for communication between the RLAN devices and the AFCs themselves. However, there really is nothing as a result of the rulemaking that is completely unsettled that we need a standards process to address. At least that's certainly Federated's view, and that solutions could proceed forward based on the FCC's rules and a certification process to ensure that incumbent protection is fully satisfied, where solutions could be a little bit more proprietary to a particular OEM's product. So I think there will continue probably to be some good standards discussions. A lot of work at the WFA, at the WIN Forum, but quite frankly, I think the jury is still out as to how much of the standards are really required to get us to certification and actually field an AFC. We believe our AFC is ready to go today. We could bring it to certification based on its compliance to the FCC rules if a certification program was set up.
Speaking of which, I know that we gave some advice to the FCC about things that they could do or maybe avoid doing with regard to certification, given what we went through with the SAS certification, which took a lot longer than people had hoped. Could you maybe talk about some of the recommendations that we gave to the FCC and why we think this process could, be done in the next few months, and that we could even see commercial product available by the end of the year or early 2021?
Sure, yeah. Certification of the spectrum access systems and environmental sensing capability for the CBRS band were fairly lengthy processes. And to, industry's sort of credit, this was complex, it was new. We now have many learnings that we can draw from as part of that certification exercise to, I think, greatly accelerate the process with the FCC going forward. I think, one key opportunity is, given that each of the AFCs do not have to peer with each other and aggregate protection requirements are not required, single entry assessments as I described, it is possible that creates the opportunity for different AFC implementations. In other words, there could be one standard, effectively the rules that are set by the FCC, by which every AFC needs to perform at least as well as that, but you could obviously bring more conservative solutions to the market. And that creates a good deal of flexibility in terms of how the FCC would think about certifying each of these different implementations. You don't need a test program that ensures everything complies to the same result, as much as show that as long as the result is at least is no more aggressive than what the FCC standard sets for protection, the solution would comply. Similarly, I think there are other frameworks that were used, like the OET's framework for device certification, and using independent test labs could be a way for this process to accelerate or move at the pace of commercial activity. For CBRS, we had to certify through a government entity, the ITS test lab. But if a certification program was pushed out to multiple test labs and done through more of a commercial process where test reports are submitted and reviewed by the FCC for approval, we also believe that would be a way to accelerate the certification. So again, a lot of lessons learned. I think we could certainly see AFCs fielded by early next year, late this year. Really, it's all at this point contingent on where the FCC falls on its, lands on its certification process.
Right. I know we're waiting on the FCC for a couple of important things, one of which is, as you were just describing, what the certification process will be, how companies who have AFCs should go about submitting their applications for certification. There's also another really important component, which is making sure that that universal licensing system database is as up to date as possible and as accurate as possible. And that's something that we had to go through in the CBRS band as well. And that took some time to work its way out. But I think for the most part, the incumbents realize how important it is to have accurate information in the FCC's database, and therefore they're incentivized to update that and make sure it's accurate, since that's the basis of the protections that we're implementing here for them. Maybe you could talk about how using a cloud-based system makes it easier for us to make any adjustments to those protection criteria should an additional incumbent come into the market, or an incumbent needs to change the parameters of their operations, or we find that the protection criteria was either too conservative or too aggressive, and we need to make an adjustment from that perspective.
Right, Jennifer, as you described, all of those things can be done in a cloud platform or a cloud-based solution for the AFC. The key benefits of a cloud-based solution are the scale and efficiency that you get, obviously, through the cloud compute capability. It's very low cost in that sense. It encourages a fully autonomous operation, so devices can, again, through an API, connect directly to the cloud. There is no need for human intervention to configure the RLAN devices. They receive a channel availability response and can begin operation. The other key aspect is flexibility. As you described, if we were to change a protection criteria, it would be possible to push that out to all devices, without having to go through a cumbersome process of updating firmware or software in the devices. So great deal of flexibility, both from the system operator perspective as well as from a regulatory perspective. So if it's determined that the protection criteria is insufficient, you can do the same thing. You can roll that back a little bit or provide a more conservative protection criteria to make sure that incumbents continue to be protected. So it allows for continued innovation, which we think is always important in any sort of spectrum sharing scenario. One key aspect of all of this, however, is that devices would need some capability to periodically check in with the cloud platform to sort of do a check-in or reconfirmation of its channel assignments or channel availability calculation, so that as conditions change, that information can be updated for each RLAN device. So, the frequency or periodicity of the check-in process is something that I think industry is still, thinking about how frequently that needs to occur. But that would, Jennifer, be sort of a key aspect of operating with a cloud solution to achieve the goals that you described.
Right. I think the FCC is requiring once a day at a minimum for the 6 gigahertz devices. That's a lot less frequent than what we do in the CBRS band, obviously.
Right, because in CBRS, we have dynamic incumbents that move around, turn their systems on and off. And because of that, we have to be more responsive. We require, a more granular check-in process in order to provide incumbent protection. But right, once a day is sort of the FCC minimum today for the 6 gigahertz band. AFC providers may decide, and OEMs may decide that a more frequent check-in process is beneficial because of potential changes in the environment.
Yeah. So we've got a question from Ian Marshall regarding privacy laws and having information about incumbents and probably as well as about the new entrants in the public domain. Obviously, that's something we went through in detail extensively in the United States in the CBRS band in particular, given the federal incumbents, the military, as well as those commercial entities whose information is a lot more public. Maybe can you talk a little bit about some of the privacy issues that we went through in CBRS, both about the incumbents and about the new entrants, because that's obviously going to be a big issue, as well as companies have competitive information that they wouldn't want out into the public domain. So we had to go through that with the
Sure,
FCC
yeah,
as well.
Jennifer, as you said, there are a couple different categories of sort of information and how we make sure that privacy is maintained. For federal incumbents, for the U.S. Navy, we are not allowed to store or retain any information related to their use. Everything that we do to protect a federal incumbent needs to be transactional, meaning if we detect use of the band in a particular geography at a particular moment in time on a particular frequency, the spectrum access system for CBRS needs to take an action, but we can't store or record any of the information related to that or even share it with other entities to assure the operational security for the U.S. Navy. For commercial incumbents, while that information is available in publicly accessible databases, we similarly don't share that information beyond what the FCC maintains on a public basis. For individual users, there are restrictions or regulations in place in the FCC rules that, for example, require us to anonymize or obfuscate information related to actual commercial uses. So we can't identify a particular user of the spectrum in a particular geography. We can instead provide things like heat maps or other anonymized information that indicate what spectrum might be available in a location or what spectrum is in use, but again, not divulging information about the particular users. And we also, as a community, have committed to not use information that we obtain for the purposes of spectrum management and spectrum sharing in the CBRS band, to not use that for other commercial purposes, to not mine that data for things that would could be used for outside of the purposes of protecting incumbents and sharing the band. So I do think there are a lot of solutions to this whole information sharing and information privacy issue, but it's certainly an opportunity or an area where regulators in a particular country or region would need to step in and, set a very clear framework by which AFC operators would need to, comply and demonstrate compliance.
Right. For instance, if the database of incumbents were a private database where the information was held by the regulator, we could be certified, for example, to get access to that database, and there could be protections put in place to make sure that we did not share that information with the public, which I think, again, we'd have to look at the individual country and their privacy laws and requirements, but I'm sure an arrangement could be made where that information did not, need to reach the public domain, and we could still access it for this specific purpose in order to manage.
That's right.
Spectrum.
And we have, as part of the sort of the information that we obtain from our customers, we of course treat that confidentially according to the FCC's rules, but we also allow provisions for customers to opt in to other forms of information sharing. For example, in CBRS, they may want to advertise the fact that they are operating a site in a particular location from a new to encourage others to utilize their capability. Customers, users of our solution can opt into that capability. And that allows then for each, particular user of the band to sort of customize what information they want to disclose publicly.
Yeah, and that brings to mind, some of the challenges that folks are going through with the 6 gigahertz band. I know we discussed yesterday the fact that most countries are looking at low power indoor devices currently. But I was suggesting that there would be so much more additional flexibility that unlicensed device manufacturers could have if they were able to operate at higher powers and operate outdoors. So many different and additional use cases could be created. I know there's been concern about the availability of the AFC and how quickly could it be brought to market, and how cheaply could it be implemented, so this would not be a burden on the unlicensed community to do this. I see there's also an issue of different formats and different requirements on a per country basis. Do you have? I mean, I know we've already been working on the AFC for the United States for many months now, and we leveraged a lot of the development that we did for the CBRS band into making that AFC happen. Could you project how long you think it might take to work with a different country and implement something for them that could enable them to allow both standard power devices and outdoor operation in the near term?
Well, accessing the databases is a pretty straightforward process, so long as it's electronic in nature, meaning that it's it can be accessed through some sort of query or API. For actual the process with the ULS, gathering the data and accessing it is very straightforward. It's really more the challenge sometimes is parsing the data and interpreting some of the records in the database. If the records are, sometimes they're not complete, or you have duplicate records and other things. So it tends to be more if the database is really in sort of a very clean form, meaning the data has really been scrubbed, updated as you described, Jennifer, then the actual process of interacting with the database is very straightforward. I mean, quite literally, a software developer could interface an API in a couple of days and test it and verify its capability.
Yeah, yesterday we were asked if we could find one word that would describe what regulators could do to make spectrum sharing easier, and I suggested that automate things would be really the thing that they should focus on. And I agree. I think making sure that they have a database that's up to date, that's accurate, that is easily interfaced with, really should be the focus of the regulator, as well as obviously establishing the protection criteria for the new incumbents and any privacy issues and competition issues that need to be addressed. But other than that, the commercial sector can quite readily adapt available technologies to different scenarios and help with some of these spectrum management challenges, so long as the regulator's database is again automated and electronic and
that's
and
right.
available.
I mean, certainly electronic and available is is key, but the accuracy of the database isn't necessarily a precursor to sharing. We can adapt to some level of inaccuracy in a database by being more conservative and allowing the database to evolve and get more accurate over time. So I totally agree that it's super important to have accurate data. That's how you get to the best outcome for sharing. But it's not like a multi-year database update process needs to happen before sharing can even begin. We can work with whatever data is available and continue to evolve the solution as the data becomes more accurate.
And that holds true for the new entrants as well in their position location accuracy, right? I mean, I know there was a lot of discussion yesterday about indoor devices not having the ability to self-locate. Maybe you can talk about how that's relevant to this as well, and how we account for that position location.
Sure, yeah. What we do with our AFC solution is we assign a location, where we acquire the location from the RLAN device, but we also have an uncertainty factor that we apply, which would be ascribed to the method by which the geolocation is determined. If it's GPS, the uncertainty factor obviously would be a lot less than if you just entered a street address. And that uncertainty factor then creates sort of a buffer zone around the RLAN operating area that we utilize in the interference calculations or incumbent protection calculations to assess channel availability. So same thing, we can work with different forms of geolocation. We can work with different levels of precision of geolocation and adapt the calculations according to the level of precision available. GPS might also result in much higher, availability of spectrum, because we can be more precise about its location, but it's not to say it's a one-size-fits-all sort of solution.
No, I think that's right, Kurt. And to the last question I think we've got here, the thing that we also wanted to impart is that all of this technology has already been developed. It is commercialized today. TV white spaces, a similar type system, has been around for quite a few years. Obviously, we're running commercially in the United States in 3.5 and hope to be operating at 6 gigahertz in the coming months. But the same capability can be applied to other bands and other situations. It doesn't have to be a one-size-fits-all. It is not specific to a particular frequency band. In fact, we discussed yesterday the possibility of applying it to the 3.8 to 4.2 band and the FSS incumbents that are there. And obviously, it's going to depend on how extensively those bands are used by the incumbents, how much spectrum will be available for the new entrants. But all of the same techniques and experience that we've learned at 3.5 and hopefully at 6 gigahertz will be applicable to 3.8 to 4.2 as well. Great. Well, thank you, everyone. We really appreciate your time and your questions. And please feel free to get in touch with us if you have any follow-up questions to what we showed you here today. And we look forward to working with the European community as it looks at 6 gigahertz and 3.8 to 4.2 and figure out how we can more efficiently use spectrum and enable new users to get access to critical spectrum to support their needs. So thank you.
Thanks, everyone.